Okay, welcome to Mr. Math YouTube channel. Today we're talking about exponents. I want to take a look at exponents other than just putting them into your calculator and getting a result. First, let's take a look at what an exponent is. Basically, what you would see is a number raised to a certain power. Now, what this is telling you is that is the number of times I'll say a number again, is multiplying to itself. Basically, the idea that a power, so basically this number being a power, and the number of times this is to be multiplied by itself is the power of which this number is being raised or is raised to. So basically, how many times this number is going to multiply itself is in fact the power, and this is this number here that it's going to be raised to. Now, just a couple examples. If you look at a 5 squared, that's simply just a 5 times 5, or a 25. If you look at a 5 to the third, that's saying that you are going to multiply this number 3 times to itself using this number. And the power is basically how many times you're going to do that. So I'm going to multiply 5 3 times, and I'm going to multiply it by itself 3 times. Okay, now you can look at this kind of like a factor tree, and then get your 125 here. And this is kind of your idea of exponents and how this is multiplying. There are a couple special cases. For instance, if you end up with a negative sign, I like always drawing attention to this, the difference between -3 squared or a quantity or parentheses of -3 squared. Basically, when you're using exponents to work with negatives, this is saying just 3 times 3 or -9, because this is saying to you that we are just raising the 3 to a power of 2, not the -3. This 2 is only applying to the 3 here, but when we put in parentheses, we are saying that we are doing altogether this -3 times a -3 and get a negative a +9. That's a good little trick to remember. It's a good foundational principle to remember. This will be used on an SAT time and time again. They'll test you on that. It'll be hidden. And then they'll also present maybe that fractional or a fraction raised to a power and the confusion here. But this is just simply 2 squared 4 over 9 squared 81. That's simply all you're doing there. Now I want to take a look at exponents as far as exponents when they're raised to a power of 0 or 1, and what happens there. What happens with exponents raised to a 0 power 1. So if you put 5 or any number to a 0 power, the idea that is it's going to be equal to 1. Now basically the understanding here is that you are not multiplying 5 times 0. You are basically multiplying no numbers at all. I'll use this symbol a lot for numbers, no numbers at all. So if you're not multiplying any numbers at all, basically you're just multiplying this number that doesn't exist by 1, and any number multiplied by 1 is 1. They call this a multiplicative identity here. And basically it's just we are not raising this number to any power, and if we're not multiplying any number at all, then the answer here will just be 1. So anytime you have a number raised to a 0 power, just kind of remember that it's going to end up being 1. Now, if you have a number raised to a power of 1, basically you're just saying this is just 5, because you're not multiplying by itself, you're not multiplying by 1. It's just being raised to a power of 1. So it's basically only multiplying by itself 1 time. So 5 to any power is just simply going to be 5 here. You're not multiplying at all. Now, another thing you have to be conscious of is when you have exponents raised to a negative power. So maybe you have a negative number for an exponent. Now, a negative is an inverse. So if I have positive 8, the inverse of a positive 8 is a negative 8. The same will go for exponents. So if I have x to the negative x to the 2, the inverse of that would be x to the negative 2. Now, what does that mean? Well, basically that's saying, well, what is the inverse or opposite of x to the 2? It's 1 over x to the 2. Think about it when you have like a problem where it's 2x is equal to 8, and you're dividing both sides by 2. Essentially what you're doing is multiplying by its inverse. You're multiplying by 1/2. This is the same thing as dividing by 2. So anytime you have a negative exponent, what that's doing is it's bringing this number to the bottom here. And if you had a exponent on the bottom, negative, it'd be bringing it to the top. Just a example where you're dealing with actual numbers would be, let's say I did 3 to the negative 2 and making this 1 over 3 squared or 1 over 9. So first bringing this to the bottom as a denominator, making an inverse, and then squaring that number. You may also end up with, like we saw in the previous slide, where you have a fraction raised to a power, and they're giving you an inverse of that. Basically, the inverse of 5 over 4, if you were solving this, if you were solving for this, 5 over 4x is equal to 10. If you want to get rid of this, you would multiply by its inverse. Basically, it's -1 version. So same thing here. This is going to be inverted. It's going to be turned into reciprocal and then raised to a second power, giving you a 16 over 25 here. Don't forget you're applying this exponent to both numbers here, top and bottom. Another good thing with exponents is sometimes you'll have fractional exponents. And this is usually where students start to get a little nervous, a little shaky. Well, what does this mean? It seems to be a lot. Fractions tend to scare students. It's not a big deal as long as you look at it and try to understand it in a certain way, basically, of what's going on. So we know 4 squared, let's say, is 4 times 4 or 16, okay? And if we're doing the inverse of 2 as a number, we would say that's 4 to the 1/2. Now, what would be the opposite of squaring something? The opposite of squaring something is taking the square root of that number. This would be the opposite. So 4 to the 1/2 is to be the opposite of 4 squared, would just be the square root of 4 or 2. Now let's take a look at that a little bit more here. So let's say I give you a fractional exponent where it's 9 to the 1/2. Okay, basically that's just saying square root of 9 or 3. We get that. But what if we did where there's a top and bottom number, like a 16 to the 3/2? Well, look at this as two different numbers. Look at it, one as the 16 to the 3rd, and the other as 16 to the 1/2. What are both those things doing? Well, one is cubing the number, and the other, the 1/2, is taking the square root of that number. And kind of order of operations wise, we want to work with this number inside first, and we'll say square root of 4096 and square root of 4096. You could take your time to do it. Punch in a calculator probably will help to speed things up, but actually end up with 64. And basically what we've done here is recognize that in any fraction, your top number will be your power, and your bottom number is basically your square, or we would say kind of your root number, because sometimes it may be a 3 or a 4. So anytime you're getting any number, I just give you 60 and you have the 1/4, This number here, if it is on the bottom, is the number that is going on the outside of the box. This number here is what's going on the inside of the box. This is the power, this is the root, just like we kind of mentioned here. And yeah, you could end up with some negative, where you have the negative 16, let's say, to 3/2, a little bit different. Just, again, take the inverse, that's a 1/16, and then you'll do your 3/2 here, and it'll just end up being 1 over the bottom number square root, or second root of your 16 to the third. That would be if you did have a negative here. Remember, math is easy with hard work. Thanks for stopping by.